Hi, welcome to this video on random forest. This is the follow-up video to my earlier video on ensemble methods. You should know cart and decision trees before you can understand this video, so I suggest you finish those videos first. In the decision tree video, we saw how cart techniques iteratively branches a dataset to reduce something called a Gini's impurity. And in video on ensemble methods, we saw a bunch of weak learners when stacked together often results in much better performance than any single learner. In this video, I'm going to talk about a method to stack together these trees and see what happens when we grow an entire forest of these trees. We can start with either a classification problem or a regression problem, but as you would see, in essence a tree is a representation of data. It's nothing beyond parameterization and storing the essence of data as a model. You would have understood by now by watching cart videos how cart would go through all the columns or features iteratively and then chop this data in multiple ways and then identify the best possible chop which results in the highest reduction in Gini's impurity, and it's that chop where it splits and then it does so recursively, growing a tree. Now it so happens that the way these trees are formed are very sensitive to changes in the data, because if we change this data slightly, then the same logic might not apply. If we change some part of this data, then perhaps there might be a other chop which gives a better reduction in Gini's coefficient, changing the entire structure of the trees. It might be possible that the current chop is no longer the best one, and when the model again recalculates on the changed data, it arrives at a different branching logic. So a tree, while it looked like this, with a tiny change in data might turn out to be like this. So it is this property of these branches that we exploit, and then we use this property to create different type of trees given the same data set. This type of mechanism where we create n type of trees and then combine these to get a model more robust than any of these individual trees is known as ensemble method. Now if in a model, if all in an ensemble, if all the models are trees, are decision trees, then the model is known as random forest. Now it's not necessary that we have all the models as trees. We can use different families of models for each of these models. So example, if our model 1 is linear regression, model 2 is a KNN, model 3 is a naive Bayes, and model 4 is a decision tree, then this just becomes an ensemble model. An ensemble model special case would be when all the models which are stacked together, if they are decision trees, then the combined model is called a random forest. Now, as we saw in our last video, that there is no value in creating a forest where all the trees are of same type, because they would yield same predictions, and there is no benefit to be gained by combining all predictions which are same. So the most popular way to grow these trees which are a little different from each other is called what is known as bootstrap aggregation or bagging. We would discuss more about these in the next video. So for this video, a quick recap that multiple models stacked together often performs better than a single model. If we are stacking multiple models, we can use any model or different families of these models for each way we combine the model. So we can stack together a linear regression, a naive Bayes, a KNN, and a tree together. However, if we stack together a bunch of decision trees, then the model is called random forest. Now, each tree has to be a little unique in its own way, and hence we would want these trees to be grown a little differently. We do this by methods like bootstrap aggregation, which we would discuss in next video. For this video, we stick to understanding random forest. So the way this works is we have a data set, we grow a bunch of trees in some way called bootstrap aggregation, so that all these trees are a little different from each other, and then we pass our test data through all of these models, which give us n number of predictions if we use n models, and we average out or count the most popular prediction, and that would be our combined prediction. And often our combined prediction is much more accurate than prediction by any given individual tree. So this bunch of a little diverse trees is what is known as random forest. In our next video, I would talk about how do we grow these random forests, how do we make these trees a little diverse, and how do we use the same data set to develop different models by using a method called bootstrap aggregation. I hope you like this video. If you like, please don't forget to like and subscribe. Thank you.